Welcome, Math 20-1, to Trigonometry, Lesson 4, a few special triangles. I'm going to ask you at this particular point to do some notes from scratch, either in the back of your book where it says Note section, because that's what it's for, and I intend to use that fully. If you wish to try to use the book, I'll fill you in as to where it is on page 167. However, I would prefer that you see this from scratch because I like to build things from scratch. So today's lesson, if you go back to the end of the book there, fill in your notes, we're going to look at a few special triangles. We know that no matter what kind of situation we've got, we have circles. I have a superimposed 3 of them here. That no matter what, if we're given a point on a circle, I guess I should use a different color. Maybe a nice bright red. I don't know if that's visible or not. Ooh. You can draw the terminus from the origin. I guess I should have picked a different color. You can draw the terminus on that point. You can label the point, all you want. And then subsequently, let's just zoom in on there. You can draw a triangle. Namely, you have a y value, you have an x value, and you have an r value. That much we know how to do already. We can get all our trig ratios. We have a referent angle right here. And we can figure out sine, y over r, x over r for cos, and then y over x for tangent from the referent angle. We can also do all of this in any quadrant we want, knowing that we have a negative x over here. Whoops, that's an ugly little thing. A positive y over here. So if I put a point up here, draw a straight line, the terminus, yoink, right there, like that. I can formulate a triangle. Okay, and they're all right triangles, of course. Negative x over here, positive y, not negative y, duh. We can do it all 4 quadrants. Now, there happens to be a few triangles that are unique than all the rest. Now, the book tries to lay it out in different ways, and I'm not going to do that exactly the way they do it. That's why I'm going to go from scratch over here. The first one we're going to do is, now, can I even see if we have one here in my shape dispensary? Yes, I do. Got to find the no-fill triangle. There it is. That's the one we're looking for. Grab the corner. Beautiful. Okay. So, start by drawing one of these. And it's very unique. Ready? Here's what makes it unique. We got some blue. One. Ta-da! I hope you know the name of that triangle. If you don't, that's okay. Let me just type that out for you. Click. It's way too big. Oh, man. That is going to be difficult. Click. There we go. That's better. Haha. That's an equilateral that you learned a few years ago. Now, there's some properties about equilateral triangles that you have to have prior knowledge. Namely, 1, all the sides are the same. Number 2, all the angles are the same. And the third axiom that you get to remember, although when I took a geometry course in university, it took 3 months to prove, over centuries of learning, that the sum of the interior angles all add up 180 degrees. Thus, because they're all the equal angles, it's 180 divided by 3. You can tell what each angle value is on an equilateral triangle. All the green angles are exactly 60 degrees. There's a 60, there's a 60, and that's also a 60-degree angle right there. So far, so good. Hooray. Now, here is what I'm going to propose to do. I'm going to make this quantity of the side length, to save ourselves some headache, 2. I don't like the green. I don't know if you can see that or not. 2. 2. 2. Now, there are a couple approaches. I tend towards this one, that 2, 2, 2 makes sense, just like we did with our quadratics, for a particular reason. I'm going to do something. I'm going to be accidental here, and I'm going to drop a perpendicular. That's right, I dropped something. I dropped a perpendicular. Now, why does that matter? Well, guess what? I split this distance, which we didn't prove, exactly in half. And as such, this quantity of distance right here is exactly 1. That's why. So, let me just move this over here and redraw a very brief triangle situation of what's going on. This is really important. There we go. That's a right triangle. Very important. All this trigonometry so far is right angle trigonometry for a reason. This is 60 degrees. This is exactly 2. This is length is exactly 1. Remember that this is the hypotenuse. This is the adjacent. Back to the old school terms. Okay. And then the question is, what precisely, exactly, oh, by the way, that's 30 degrees because I split the other one in half from here, right there, over there. It's actually this triangle right here. It's also the same the other way. What is exactly this distance vertically, which is our opposite, which will be our y component? Well, doing some Pythagorean theorem, this is what you get. Okay. So this means this is one of the special triangles which you get to know. That when you have a 60-degree referent angle, a referent angle of exactly 60 degrees, you have an adjacent or an x value of exactly 1. You have a y value of exactly 3. And then you have a hypotenuse, or technically a radius, of 2. But wait, there's more. Let me just do a little bit of erasing here. And let's do some labeling carefully. Ready? I don't know if you can handle this yet. Get rid of this, get rid of this, get rid of this. Need to move this over. There we go. Voila. Are you ready? Here it goes. I'm going to group this. Come on. All right. There we go. Whoa. 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 That. Ungroup that. That is what I'm talking about. We also have the 30-degree triangle. So when you have a 30-degree triangle, you have the adjacent length as root 3. The opposite, this time looking from this way, the referent looking that way, the opposite's 1, and the hypotenuse exactly 2. Normally, we typically draw them like this. Big, long base, short height, and a hypotenuse. 2, 1, root 3 is what you get to be familiar with for a 30-degree referent triangle. That means you have the sine, let's just say of 30 degrees, is going to be 1 over 2. Exactly. Remember the other day when there was a sine of 0.5? I knew it was 30 degrees. That's why, because I knew that 1.5 was exactly 0.5. That's why I knew it. If you wanted to find the cosine of 30 degrees, for example, Well, that's just looking at this adjacent, root 3, and then divide by 2. Subsequently, the tangent of 30 degrees, by definition, is 1 over root 3. Now is where we have a bit of a problem. We have ourselves a radical in the bottom, so what we want to do, like we said yesterday, is multiply that by root 3, multiply that by root 3, so we get root 3 over exactly 3. This is the appropriate value. If you leave it like this, it's okay. It tells you exactly what your side lengths are, but why do you get a root 3 over 3? So one thing to know, that if you have a square root 3 involved, it's probably a 30 degrees or a 60-degree triangle as a special exact value for parts of the trig ratios. These two triangles need to get memorized. Again, I'll redraw them from scratch. This is what you have to be able to quickly do in a problem-solving scenario now, that if you have drawing a triangle, this is the big base. The big base is square root 3. A little high, 1 and 2. This is a 30-degree triangle. Subsequently, drawing this right, tall triangles, very, very tall, have a very short base of 1, have a very tall value of root 3, and a hypotenuse of 2. By the way, this is about 1.7. That's why you know how you fit the sides. Root 3 is 1.7, not quite 2, and 1 is much smaller. So that's how you know and understand this is the 60-degree triangle version versus the 30-degree triangle version. These are the two basic triangles, and from there you can see all the trig ratios if you compare the sides. Opposite, adjacent, hypotenuse, back to those basic definitions. Have I finished, Mr. Weebin? No, I have not finished. We're going to draw one more geometric shape. One more, and only one more at this particular point. This one. Okay. Ta-da! I hope you all recognize that without me having to explain it. Blue. Okay. We have ourselves this shape, which has these particular characteristics, very much like the equilateral. It has all same sides, all same interior angles. All those interior angles are 90 degrees. Woohoo. Fantastic. But, kind of like what we did before, but not exactly, we're going to split the shape in half. Whoa. Now, the question is, what is the best choice for the side lengths? That's why I was taught that the best choice is 1 and 1 for the side lengths. It helps, but it can cause confusion in the real world when you don't have exactly ones. Like the first time I ever cut like a 2x4, where the 1 is the width of the 2x4, and trying to cut a 40. I was trying to cut this thing, and it was 3.5 or 3 1/4. Wasn't exactly the same idea. A 1-to-1 ratio, though, is. Now, if this was 90 degrees here, this is the thing that gets split in half. Now we have a referent angle of 45 degrees. The real big problem here is, what is this exact hypotenuse? Or, when we do it, radius. Okay, when we place it on a circle on a Cartesian plane, it's 1 squared plus 1 squared, which is 2. But that's the r squared. Thus, we have to do this, and we have to do this. This shall be, and precisely, square root 2. Okay, I'm going to redraw everything from scratch really quickly. What is it? Drawing of this almost the same size this time with a 1-to-1 ratio. There's your tangent. And if I was to draw the classic 45 degrees, There's 1, 1, and root 2. Voila, we have got ourselves the 45 special triangle. Now that we can figure out the sine of the angle, you can do that. You can figure out the cosine of the angle, you can do that. And the tangent of the angle, you can do that on your own. Please be advised, for sine and cosine, you are going to have a root 2 on the bottom. That's not nice. I'll leave you to do that. Quick little summary. Again, your teacher, whoever supervises you, can pause. When you see trig ratios and you see the following, I'm just going to switch colors just for the sake of, whoa, I could do it like Khan Academy. When you see one of these, the 3, you can assume you're dealing with either the 30 degrees or the 60 degrees. That's a little helpful little note here. Let me go to red. When you see the square root of 2, that means you're dealing with a 45 degree reference triangle. You just have to know how to draw them to know which one's the 30 or the 60. You have to decode the rest of that information there. Okay? So now that we have these basic triangles that are special, there are more, but it's as far as we're going to get to today. I need a special other lesson alone to conceptualize the other ones. We're going to now solve angles and ratios as we place these things. Let me go back to my backgrounds. Okay. As we place these triangles, I guess I should zoom out and find out where I am. Whoa, I'm really large there. As we place triangles in different quadrants, okay, let me just draw a little triangle. We can place a quadrant over here, put a terminal arm this way, put a terminal arm this way, and then we say, let's make a 45 here. 45 degrees. Okay, well this would be -1, -1, and root 2. Now we can figure out information about those values. Exactly. The rotation angle would be different. Well, I wonder what happens if I change the background now. I guess the Cartesian plane would disappear. Watch it go away. Whoa, it inverted. Cool. The rotation angle could then be figured out if we had it this way here. Also, if we had the standard position angle such that we got, 180 plus 45 is equal to 225, we can figure out all the trig ratios now of 225, like sine of 225, or cosine of 225, or tangent of 225, with their exact values, because they have the same special referent triangle. That is where I'm going to proceed to in the workbook now. Please pause the video, get ready to go to the following page. I'm going to switch my background back out to white. Click, 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 click. Close that. Next page. Just going to skip over that. Going to skip over that. Going to start with the idea of class example 1 on page 169. That's where we're going to begin. Again, I don't think there's enough space to draw here. So on page 169, there's a little bit of space. I love drawing things, so that's how I'm going to approach it. All right, I'm going to zoom in because I get to zoom in. Here we go. It's massively large. It says find the sine of 210 degrees is the very first one. Okay, procedure does not change. This is where it's the most important, so that you can see where you are. The first thing you ought to do, I can use technology. Haha. Plus I can copy and paste for the next ones. You draw a circle. Absolutely. You put yourself, that's not the one I want. I want a black one for that. Draw yourself a Cartesian plane. There we go. Cartesian plane drawn. Okay. Rotation angle. Here we go. That's a 210. Oh, that's a straight line feature. Haha. Got to do this in pen. So going around, there's 180, and then there's a bit more. This shall define the answer of the terminus. Okay. If this chunk right here is 180 degrees, right here, the referent angle is what's left over. 210 minus, 210 minus 180 is a 30-degree referent angle. That's how I know what's going on here. 30 degrees. I'm going to zoom in a little farther now because now I can focus. I think I've maximized my zoom feature. Now, that is the information I need to draw this on the Cartesian plane. I'm going to go back to black. This is x. I'm going to put a dotted line here, or at least the y component there. Okay. If this is a 30 degrees, I'm going to need a little space here. Okay. Zoom in. Click. Once more. All right. If this is 30 degrees, this is the square. I'll change colors. Blue is a little nice. This is the square root 3. This is the 1. This is the 2. We're on a Cartesian plane, though, so what has to happen, they pull the punk move right off the bat by saying, uh-oh, do you recognize that we're on this side of the plane? That's a negative 3. And if we're down here on this point, we're at negative 1. This, in fact, is the coordinate negative root 3, 1. If the radius is 2, by the way. Let me just take a step back on that one. If the radius is 2, because we can make circles bigger or smaller, all we want. That's why I like to use this using as a radius of 2, because my numbers are exactly as they appear, or at least what I can see. The question is to find the sine, the sinus. The sinus is the opposite over the hypotenuse. Clearly, if you can see them, that's why I like drawing everything, you know the answer. So going back to what is sine of 210, that by definition is y over r. The y value is negative 1. The r value is 2. There's the sine of 210. Should you be in utter shock and disbelief, you can always check if you did it right. Sine 210. Lo and behold, see with your own eyes. The sine of 210 is negative 0.5. If you hit the math button, this is the limitation of the calculator, math fraction, you should only be allowed to see negative 1/2. That's the maximal idea that you can see exactly. Although conceptually, you're supposed to get that without the use of technology. That's the whole point. Okay, let's move on to the next one, shall we? Again, if this is fast, you can talk to your person supervising at this particular point and say, can you please slow down or go back? See, Mr. Weibman can do this for the next question. Nice. My circles can be redrawn. I'm going to draw the Cartesian plane. I'll just keep it in green for now. And draw the rotation angle. Put that back in blue. 300 degrees. Okay. There's 300. A terminal arm is coming. So if a full circle is 360 degrees, a full circle, what's the referent angle here? If this is a 300, here, what's left? The leftover is the referent angle, which is really important. How much do you have to get from 300 to 360? The referent angle is a 60-degree triangle. That means that's the one really tall, okay? And now this time it's upside down, root 3, that's the tall one. The short side length is 1, and the hypotenuse, or the radius, is 2. Let me just zoom in on that one. Okay? But what am I missing? I'm going to want to do this right now. Really fun black color. That didn't turn out the way I wanted it to, so ignore that. Sometimes you failed. This is positive 1 because we're going to the right. The root 3, however, is negative because it's headed down. That's really important here. So the question was, for this particular one, was find the cosine. The cosine is the adjacent over the x over r. This is the x value. This is the r value. Cosine equals x over r of the angle. 1, that's positive, over 2. There's the cosine of 300. Let's hope I didn't mess up. Mr. Weidman, probably should check to see if you got it right in a calculator. Sure, that's a great idea. Thanks for saying that. Cosine 300. Ready? Full screen. 0.5. Exactly 1/2. Awesome. Great job. Now let's go to the next one. On the pen tool, hands, move over here. 225. It would help if I can draw a circle. And yes, every single time you should draw a circle to know where you are in the quadrants specifically. 225. I'm going to slap on a Cartesian plane because that's what we do. 1, 2. Yes, I can go faster than you because now I have technology that moves faster than the human hand. 225. That happens to be 180 and a bit more, namely down here. Terminus arm coming out. Zoom. There it is. Terminus. Okay. If this is 180 and this is a full 225, I take away 180 and lo and behold, I find my referent angle, which is a 45-degree triangle. So when I form my triangle, this is a special 45. I'm going to zoom in. I think it's as far as this machine can go. 45 degrees. So here it is. Here's the 45 degrees. Down here, that's the referent angle from the axis. This is the 1. This is the 1. This is the root 2. But wait a minute. I am at left 1, down 1. Okay. That's nicer. This is the x. This is the y. This is the r. The definition of tangent is take the y value. I should probably write that out again because that's important to write out. Tan is y over x. In this case, it's -1 over -1. So in this case, it's going to be tan angle is going to be just a simple 1-to-1 ratio because the negative over the negative cancel each other out and you get exactly 1. I think I crashed my calculator. Let's find out. Oh, there it is. This was 225. Lo and behold, tangent of 225. Full screen. Hit enter. Why is it just a 1? Well, because the calculator has simplified the fraction into a single digit. You know this 1, this mischievous little 1, Juan, is actually a -1 disguised divided by -1. Incognito. That's when this trigonometry is going to start to get a little tough by decoding. When we get tangents of 1, what angle was it? Where was it? Where's all the pieces of the triangle? Okay, zoom out. That was class example 1. Sorry, that was 2, wasn't it? Well, it was one number 1. Okay, now we're going to work backwards without technology to see if we know what we have. Let me just double check. There's only a couple examples. I'm going to be skipping creating the unit circle, by the way, for now. I'll leave that till later. There are about 8 examples 9s for the brave of heart for a bonus if you really want to, but I'm not going to do that. Okay, I'm sticking. These are the classic examples. This is stuff you have to be able to identify. So here we go, being able to get the exact answers without technology. Yes, technology can find the answer, but it does not tell me you understand what's going on. Okay, first thing we do when solving these things is try to recognize what kind of triangle we have. Okay, cosine, by definition, cos is x over r. The x component is a root 3. Please ignore the sign with the g right now. It's a root 3. That's what we see up here. It has a r value of 2. And therefore, this is the little 1 here. That means we have a referent angle to work with, this is important, of 30 degrees. There's the first important part of this, is decoding. How did I take the definition of cosine? We know it's x over r. X is the base of the triangle. The r is the hypotenuse of the triangle. So I drew those out. Base, hypotenuse. Root 3 is the long one. Short height, big 2. That's a 30-degree triangle. So far, so good. This is where the first time ever I'm going to ask you to draw a triangle first. Then we shall proceed with our previous skill set. That previous skill set is circles. Okay, go ahead and draw a circle and a Cartesian plane. X, y, negative x. That's ugly. Negative y. Okay. I'm done there. But you probably aren't. Alrighty. The next question is really important. With no words, it's quiet. What is the sine of cos? Huh? Sine. G. It's silent. The sine of cos is right there in the ratio. This tells us where the answer z could be. It's negative. Where can a cosine end up negative? Well, that means it could very well be in quadrant 2. And watch this. I'm going to see technology. It actually can find the 45 for me, by the way. Look at that. It's locking in itself place. And so I'll just like rough estimate there. There's a terminus. Voila. In quadrant 2. Where is the other negative? Down in quadrant 3. It locks into 45s for me. But anyways, doesn't really matter. It's a 30-degree referent. Again, it's from the x-axis. This is the point. This is the point. If I was to consider this, I've got a 30-degree triangle here, a 30-degree triangle here. That's what the referent tells me, that cosine has a referent of 30 degrees. I really didn't need to draw this vertical line. That's okay. So what angles do we have? Well, the first angle is going to be this one. The second angle, if I can get it in there, there it is. There's theta 2. That angle. How do we calculate them? Well, theta 1 is 180 degrees. Take away the referent. Once you identify the referent, you're like golden here. What's the referent? 30. What's 180? Take away 30. 150 degrees. That is the first angle that satisfies. The second angle happens to be 180 plus the little referent beyond there. When you're in quadrant 3, that's the rule. And so therefore, 180 plus 30 is way back to example Juan, it was a 210. So we have two answers that we have to satisfies the equation. Let me zoom out a little bit here. Because it asks what angle satisfies that ratio. Root 3 over 2, negatively? Well, guess what? 150 and 210. How do I know I'm right? Not because I have stellar intellect alone. But what if you don't? And you're like second guessing yourself? Well then, let's use technology. Bring it in. Okay, it says without technology, but once you've done all the work without technology means you've justifiably graphed, visualized, and done some analysis here. That's what I'm looking for. That's why I asked you to draw. Because you could guess until the cows come home that what is negative square root 3, close that, divide by 2, there's the decimal. Fantastic. Was the answer of cosine of 150 one of them? Sure was. Is the cosine of 210 the same quantity? Voila. I'll put that on the big screen for you so you can actually read that. What did I do? I actually put the root 3 negative, divide by 2. There's the approximate decimal. I figured out my first angle. Plugged the cosine of that. Guess what? It's the exact same quantity. I plugged the cosine of the second angle I found. It's the exact same quantity. Therefore, I have solved those two angles precisely. It says to use without technology, because there are, in fact, ways to use technology to figure that out, but we're not using them to solve. I'm just using it to check. Okay, next one. By the way, we're going to save this for later. That's special. That's what I said. There are a few special cases that I'm not going to cover today in this particular lesson because it's a long lesson. Alrighty. So, next one. This is a unique situation. It says it's a point on the terminal arm, and we're supposed to figure out where it is without technology, and then find the value of x's and y. Okay. All I need, ultimately, is just the information. This is pretty much what we've been doing all along anyways. So when you see a point value, your gut instinct is just to go and just tackle it with a circle and a Cartesian plane. Ooh, shouldn't do Cartesian planes in red, I guess. I don't know. Boom. Boom. Now, the coordinate happens to be negative 3. That's somewhere over here. Negative 3. Probably should switch to my... What did I just do? I don't know what I just did. There we go. I should probably switch to my actual pen tool here. Negative 3 is somewhere right here. And the y value is, in fact, root 3. Positive. My terminal arm is there. Okay. Draw the angle. Standard position. Let's do that. There we go. There's the standard position. Doesn't ask me to solve it, by the way. I could, but it's not asking me to. There's x. There's y. No problem. Did it even ask for any other thing other than that? Terminal arm. Draw the angle. Standard position. Mark the point P. Check. Values of x and y. Check. And then the value of tangent. Because if you draw it out, you can see the tangent itself. Because the definition of tangent is tan of an angle is y over x. That means we have the plus 3 over negative 3. Root 3 over 3. Wait a minute. The root 3. This is the fancier, weird one, by the way. Of a square root 3. Normally when you see a root 3, that should be an automatic. It could be a 60-degree triangle, or it could be the 30-degree triangle. By the way, if this is the short side, because that's about 1.7, and this is exactly 3, that actually makes this the 30. because 3 is bigger than 1.7. Makes it the really wide one. I didn't draw it to scale. No biggie. Yoink. Moving on. Oh, wait a minute. I answered the question right there. State the reference angle. How did Mr. Weedman do that? Again. Oh boy. I saw a root 3. That triggered me by saying that must be a 60 or a 30. When I did a numerical component analysis, root 3 is about 1.7. The base of the triangle is 3, although I didn't draw it right. This is bigger than this. That must be, root 3, the 30-degree referent. That means the standard position angle is 180 minus the referent, which is going to be 150 degrees. Hoorah! I hope that was clear enough. If not, I'll have to deal with the damage later. Okay, I'm going to skip over creating the unit circle. It's a matter of scaling all these quantities back down so the radius is always 1, by the way. That's what a unit circle is. I will leave it for later. If you can draw out your triangles, it's sufficient. I'll show you its application later next year, primarily. And then, of course, if you want to memorize all the values of every single sine, cosine, and tangent, or sine and cosine for all the special triangles all around the circle, you go for it. You can hopefully see the smile on my face as I say that. I'm not a fan of it, but that's what it is. Okay, now let's go and do some more specific ones about more difficult questions. We are given the quantities of the sine of the angles, and we're asked to find the exact values. So exact values means we recognize which is the referent angle, draw it out in the right quadrant, and put the right ratio. That's what we're supposed to do. So for our first one, it's 240. Okay, 240 degrees. I am going to draw a 240. For this time, I'm going to save myself a little bit of work. Okay, I guess I should just move over and just zoom in. No big deal. Okay, I'm just going to draw the Cartesian plane. I'm going to draw my reference angle. Okay, 240 is going to go rotation, 90, 180 is all that. And then to get to 240, how much more do I need to get from 180 to 240? That tells me the referent angle of the triangle. That's a 60-degree triangle referent. That's a 60. Okay, I'm in quadrant 3. Long as I know it's 60, that's a root 3. That's the tall one. That's the 1. That's the 2. I'm in the right quadrant, or the left quadrant 3, so that's negative. That's negative. This is x, this is y, this is r. Sine of 240, any sine value is going to be y over r. So the y value is, over here, negative root 3. R value, 2. Ta-da! Moving along. 240. Oh, wait a minute. As opposed to memorizing cos 240, I can just look over here. That's why I have all the answers. And I'll just do it over here now. Cos of 240. Well, what's the definition of cos? Cos of 240. Cos is equal to x over r. I can see x. Well, that's negative 1. R is 2. There's the cos of 240. Voila. Yee-haw. Whoa. Tan 240. I don't need to draw it 3 times because I can see all 3 trig ratios visibly. Let me just do an erasing back here. Okay. Tangent, the definition. Let me just move over a little bit more space. And let's get rid of this guy here. The tangent of 240. Tangent y. Whoa, that messed up. It's glitching out. Y over x. Y value is negative root 3. Boy, it's really glitching on me here. I must be using my machine a lot. Over negative 1. That's a 3, by the way. It's not a 5. I don't know why it's glitching out on me. These negatives will cancel each other out. It's going to be root 3. I do not know why it's glitching out. Cannot tell you. But let me try that again. There we go. Over 1. Or just root 3. Often textbooks just have the root 3 without the 1 because they want to save themselves some space. Look at that. I was able to use one drawing for all 3 questions. That's the power of drawing out your problem, because then you can do more than one thing at a time if necessary. Oh boy. I'm not going to use the unit circle for the next example 5. I'm going to utilize my knowledge of where to draw things. Okay? I don't need the unit circle, but I do need a circle. Circles do come in handy. Cos 135. Alrighty. Slap a Cartesian plane on there this time, just because. Again, you might want to bring a little device that actually is a circle. Now, rotation, arm, 135. Whoops, I'm in straight line mode. Rotation arm, 135. There it is. 135 degrees. Voila. The terminus is right there. It found it for me. Anyways, this referent angle is what it's all about. So in this case, because I'm in quadrant 2, the referent angle, the standard angle is equal to 180 minus the referent angle. To figure out the referent angle, I can go 180 minus 135, and that gives me a very special number. By the way, here's a hint, 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 hint. It's the 45. Okay. Whenever you see a 5, that might be a clue. So, let's do this. I'm going to do a little bit of erasing just to clean it up there. So, therefore, this must be, by definition, put blue on here, 1 root 2. This is negative. This is positive. Cosine, that's x down here. That's y. That's r. Cosine is equal to x over r. Negative 1 over root 2. The recommendation again, get rid of that root 2. By multiplying it by root 2, you're going to get negative root 2 over 2. Whoosh. Sliding across. Tan 120. Okay. Again, I got to draw. I know this is not the most pleasant for you folks that have to sit and watch this. And if you're getting it, fantastic. I'm just making sure I'm covering several particular cases that we could demonstrate here. 120, rotational. Make sure I got my little thing on here. Rotational. 120 over here. There's the standard position that's given me, 120 degrees. By the way, hopefully you can do the mental math. How much more do you need to make 180? Well, that would be a 60 degrees. And I'm just going to sort of speed up a little bit here, drawing things out. There we go. It's a 60-degree triangle. Okay, zoom in. 60. That's as far as it goes. I don't know if you heard that big ding. I did. This is the 1. This is the root 3. This is the 2. This is negative. This is positive up here. Tangent is y over x. Y is positive root 3 over negative 1. What you're going to see is the following. Ready? Negative root 3, just as is. Where did the negative come from? Oh, down here. They often just hide it there, especially when coming backwards and solving what angle it was. Got to be careful. Special, leave it till later, another lesson. Special, leave it till later, another lesson. Takes another whole lesson to figure that stuff out, okay? Moving along, and Oh boy, that's gonna be too much right now. I will save that for another day. Calculator, decimal rotation, save it for another day. Do not need the decimals. You know what? I think I will have to like look at this one and say, okay, I need to be here. I don't know what time we're at for our video editing here. I have no idea how long this lesson is. Well, 50 minutes. Probably more than enough time I think I've spent explaining in 50 minutes. This is now the more standard of excellence, as it were, of solving problems between 2 points on a circle. This gets repeated again in Math 30-1 and understanding a few things that way. That is going to be it, I would say, right now. I think your brains are probably just tapped completely out for watching 50 minutes of math. I'm not going to do the decimal approximations right now. I'll show you those later on the next page. If you are so bold, you can see and try some of these things. This is Math 30-1, okay? Finding exact values of these, especially letter C, that's a standard of excellence even for Math 30-1, by the way. You don't even know how to do that. But if you think you can try, go right ahead. I highly doubt you can. The answers are there in the back of the book anyway. Oh, no, it's examples. You can't even do it. Haha. All right, so what should you be able to do? You should be able to remember these values from question 1. Ultimately, see question 2, I'd say you should be able to do A, B, C, D, E, no, 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 yes, yes, no, 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 yes, no. Okay, for question 2. You can pause it on the board to see what's there. And I think that's all I did for the assignment for cutting it off on the digital page. Let me just go to my actual page. Because I only think I just copied to there for the lesson point. Let's see, zoom in, page down for question 2. And let's see if you can actually try doing question 3, A, B, C. A, B, C. And if you do 4, yeah, I'd say you should be able to do 4. Okay. 3A, B, C. Whoops. 3A, B, C. And question 4. Let's go down next page. That's just a unit circle. Don't do the unit circle. Nope. Oh, yeah. Exact coordinates. Nope. No. Yeah, you could do that one. I'll do it later. And then these ones are more challenging. That's about it there. Okay. You know what? There's one more. 13. This is basically the level you're supposed to be able to do on test. Take one thing and think, oh my goodness. If you were to memorize the unit circle, you might not know how to do it. But if you draw it out, this is really easy. That's why I say to do it. Okay, 13. And that's it for the lesson today. Hope I see you soon.